Okay, firstly, hello everyone. Just like to say on behalf of both of us, it feels like a bit of a privilege to speak to you all today. We've attended many of these PWI events over the years, but generally been in the audience, so it's nice to be contributing material for a change. So, as mentioned, we're here to talk about Northern Powerhouse Rail. Hopefully this moves on. Okay, yeah, there we go. So earlier today in his keynote address, Tim Wood set out the high-level ambitions of MPR, and some of the detail I've reiterated on this slide as a reminder. But as I'm sure you will have appreciated during Tim's presentation, MPR is a hugely ambitious programme looking to deliver truly transformational change for people in the north of England. But we should be under no illusions because delivering an affordable scheme that meets those ambitions is going to be really challenging. Now, for those of you who are not aware, MPR is at a very early strategic stage of development and we're still awaiting the government's integrated rail plan, which means the exact configuration and makeup of MPR is not yet formalised. And that somewhat limits what we can share today in terms of specifics. However, what I hope we can do is to lift the lid a little bit on MPR development to date and share with you some of the more notable and novel challenges that we're working to resolve with the support of our delivery partners. So now our delivery partners are Network Rail and High Speed 2, but we're also supported by many other consultants and suppliers from right across the industry. So that's people like Atkins that I work for, Mott MacDonald that Jenny works for, but many, many others. So on the screen now we have the North's preferred network map, which hopefully you recognise from this morning. And we'll be using this as a basis to talk around during our presentation, spotlighting certain locations where we are encountering fairly unique challenges. So I'll take you through the western corridors in the first segment of the presentation. I'll then hand over to Jenny, who will take us through the eastern corridors, then we'll come together just to wrap up at the end. So, on to the first location. Liverpool and the lines out to Manchester. So as you'll be able to see on the top right of the slide, MPR is looking to not only reduce journey times, but also to significantly increase the number of fast services operating between these two great northern cities. Now for anyone who regularly travels on the train between these locations, you'll know that at present there's only really one bona fide fast train per hour on the Chat Moss. All the other trains take upwards of 50 minutes to travel between these two cities, which, to be brutally honest, in this day and age is not great. So introducing 6 express services per hour, with best case journey times under 30 minutes, represents a transformational change to passengers, so it'll introduce a true turn up and go service. And this is made even more ambitious, given this is set against the background of the introduction of HS2, and also requirements for growth in existing freight and passenger services, which is all baked into our MPR proposed timetable. Now, all of this increased rail traffic will undoubtedly result in significant utilisation of the infrastructure, but this is felt most acutely at the stations, or the hubs as we call them. Given this, it's imperative we get the hub choice right to deliver a sustainable solution capable of dealing with demand over the long term. So at Liverpool, the MPR team has developed a range of options, which include upgrades at Liverpool Lime Street, but also new station designs. Now, in relation to the options that involve Lime Street, which is the fantastic building that you can see on the image there, our early capacity analysis feasibility work is focused on making the best use of the existing railway and getting the most out of it. But this has indicated that interventions are undoubtedly required to support our future timetable. Now, these interventions have increased risk of heritage impacts given the listed nature of the station. They offer very limited scope for growth beyond MPR, so we have concerns around future-proofing, but they are seemingly more affordable than some of the new hub options. But in contrast to this, the new hub options do involve increased costs, but they do reduce the heritage risks in the station, and not only that, they offer greater potential in terms of journey times, resilience and reliability, and they provide opportunities to release capacity, creating opportunities for freight on the approach lines, but also taking services out of the existing station. and freeing up capacity. And finally, the new hub options offer more potential to accommodate future growth beyond MPR. Now, you may know that Liverpool City region and other stakeholders are promoting the development of a new gateway station to be the terminal hub of HS2 and MPR in the west. The City region has established a station commission to consider and promote options from a Liverpool City region perspective. However, for TfN to determine the right solution, balancing the ambitions of Liverpool, it's becoming apparent that given the service mix of locals, suburbans, express trains and freight on the approaches, that finding a transformational yet affordable solution that offers the right level of resilience and reliability is the real challenge. Now, with regard to resilience and reliability, Network Rail and Atkins have been helping us to undertake performance modelling to understand each option's relative performance in this area. Now, in its simplest level, this has tell us things like the number of services on minimum headways or margins or turnarounds. And doing this extent of performance modelling at such a sort of early strategic stage is relatively novel, but we feel it's essential. And gaining a better understanding of this will allow us to compare our options more effectively and ultimately to help us to make the right decisions when the time comes to select our preferred option. Now, I should say now there are absolutely no easy answers of how to best accommodate the step change in service that HS2 and MPR will provide at Liverpool, and we'll continue to develop and assess all our options while we await the government's integrated rail plan. So moving on now to look at the eastern end of the Liverpool-Manchester corridor, where a very different situation exists. Now, the current proposals for MPR send Liverpool to Manchester services via Manchester Airport using about 25 kilometres of HS2. Now, in contrast to the issues experienced at Liverpool, because HS2 and MPR will be operating similar rolling stock with similar performance and identical stopping patterns, the capacity constraints associated with a mixed-use railway are avoided and the timetable can be regularised. Now, this allows for high-speed, high-frequency running, up to actually 14 trains per hour on the Manchester Spur, which is quite a lot for what is predominantly a two-track railway. Now, this integration has resulted in several alterations to the HS2 proposals, and primarily this is 2 additional platforms at Manchester Airport and Manchester Piccadilly High Speed Station, which is shown on the artist's impression there. And both of these stations require enhanced facilities to deal with the increased numbers of passengers that will result from both of these schemes. Now, aside from taking advantage of higher speeds and the capacity benefits, there are other advantages to sharing the route with HS2. Firstly, by delivering a single integrated railway, we minimise the infrastructure, we also reduce the costs, and we also reduce impacts on neighbouring communities, and we maximise the value of the HS2 infrastructure into Manchester. However, operating MPR and HS2 together does introduce a range of unique technical issues. And to name a few, firstly, in terms of systems integration, at each interface with HS2, it's necessary to have what we call a systems handover, where there is a transition from MPR to HS2 power and train control systems. Now, this handover ideally requires about 1 kilometre of track at surface on a shallow gradient to allow transition across a neutral section. And it also requires coordinated arrangements between organisations for the maintenance and operation of their respective systems. Now, in terms of rolling stock, the MPR vehicles that operate on HS2 must be fully electric, which drives wider route electrification with its own challenges. They also need to be able to adapt to call at HS2 stations which have differing platform heights from those on the conventional network. So our MPR vehicles will need specialist adaptations to deal with variations in the platform interface, which is quite novel. So as you can hopefully see from this, integration with HS2 infrastructure does give us significant advantages, but requires careful consideration of some complex and relatively novel technical issues. So moving on now to Manchester. Now there's so much I could have chose to discuss here, but I wanted to concentrate on something that was mentioned earlier, which is the current performance issues that are being experienced in the South Manchester area. Now this is important for TFN for two reasons really. Firstly, we need to ensure we identify appropriate solutions to resolve the reliability issues in the short term. And secondly, we need to resolve this in a way to facilitate the long-term strategy, which involves MPR, but also has other interfaces with TRU and HS2. So to recap on the history, May 2018, there was a timetable change which caused widespread and repeated disruption, which is ongoing, although the COVID-related timetable has changed the picture somewhat, and I've included a train punctuality graph there just to illustrate. The Castlefield corridor was declared congested by Network Rail back in 2019, and in response, the industry set up the Manchester Recovery Task Force in January 2020 to help to find solutions. Now, the task force includes representatives from the Department for Transport, Network Rail, Northern, TransPennine Express, Transport for the North, and Transport for Greater Manchester. And it's the first working group of its type to include such wide representation to address a congested infrastructure issue. So concentrating first on the short term, in the initial phase of work, the task force has proposed 3 options for timetable changes to make the network more reliable again in the short term. These were put out to public consultation earlier this year, and although discussions are ongoing to finalise the exact nature of the changes, whichever option is selected, there will be a reduction in the number of services through the Castlefield corridor. Now, this is clearly not a sustainable or acceptable solution for the North, and is not in line with the proposed levelling up agenda. So given this, in the second phase of work, the task force is now focusing on identifying the infrastructure interventions needed to further improve reliability and to increase capacity. Now, TFN has a crucial role to play in this phase, and that's to ensure the task force gives due consideration to short-term solutions that also contribute to the achievement of longer-term objectives. So in short, providing infrastructure that's complementary to MPR and supports the other major programmes to provide a suitable foundation for implementing Transport for the North's long-term strategy. Now, promoting solutions that deliver some MPR requirements early is also beneficial to the eventual implementation of MPR. Now, I'm sure you will appreciate from looking at the map, MPR will need to build a huge amount of infrastructure across a massive area, and to attempt to do this all in one go would lead to widespread disruption and supply chain issues. Peter alluded to that earlier. Now, this would be really challenging to mitigate, obviously, because HS2 and TRU are underway at the same time. So bringing aspects of the work forward will make the eventual phasing challenge easier to overcome. Now, this work stream is, of course, ongoing, and TFM will continue to represent the North's short-term and long-term interests within the task force. So moving on now to the Manchester to Leeds corridor, there are 2 clear alternatives here. Options with a mixture of new and upgraded infrastructure serving Huddersfield, which are building on TRU and enhancing it, and options involving new lines serving Bradford. Now, to achieve the journey time improvements shown on the infographic, operating at speeds up to 125 mph will be necessary. So the principal challenge for this corridor is, of course, the Pennines, where the level difference between Manchester or Leeds and the highest peaks is as much as 400 metres. And in many locations, the gradients are just far too steep to build a railway. Now, for all you track designers in the audience, you'll know when you design a railway at 125 mph, there's not much scope to bend and shape the alignment to fit challenging terrain. And where we do, on this corridor where we do actually find topography that's more favourable, it's generally already been developed, so someone's built a road or residential area or something else in that area. And obviously introducing MPR there would be hugely disruptive to local communities. The route also has to contend with pretty limited road access in the central sections of the corridor, which will make buildability, maintenance and evacuation more of a challenge. And it's in these areas where it's also imperative we minimise impacts on a high concentration of triple SIs in the special conservation area on the South Yorkshire Moors. So considering all these challenges, it's become clear that any options developed for MPR must consider the use of really steep gradients, up to 2.5% or 1 in 40 in track speed, and some degree of tunnelling, with a typical maximum depth of 200 metres. Now, to use a northern analogy, that's equivalent to the Blackpool Tower with 2 angels at the north piled on the top, so it's a long way down. Now, these tunnels will not be the longest or deepest tunnels in the world by any stretch of the imagination. However, they will be some of the longest and deepest tunnels ever constructed in the UK. And given this, we face a challenge of how tunnel ventilation, fire and evacuation is effectively managed within the chosen route design. Finally, there's more to be understood about what is in the ground. Now, from what we know, these tunnels will be bored through hard abrasive rock, typically millstone grit, which will present different challenges to those faced in other contemporary UK rail schemes and in other areas of our network, for instance at Liverpool where it's sandstone. And early information will be really crucial for us to determine the construction methodology and help to manage risks, particularly those associated with historic coal mine workings, which are especially prevalent around Bradford. So to quote one of my daughter's favourite books, we're almost in a can't go over it, can't go under it sort of situation, and MPR will need to challenge standards and utilise expertise from across the global engineering community to help us to deliver the solutions required on this corridor. So this concludes the Eastern Corridors portion of the presentation. I'll now hand over to Jenny, who'll take you through the Western Corridors. Thank you.
Thanks, Simon. Okay, I'm not going to talk for too long because I'm sure you're all ready for some coffee, so I'll try and wrap it up quickly. So for Leeds to Newcastle, to achieve the frequency and end-to-end journey times between Leeds and Newcastle that you can see on the infographic on here, we can make speed improvements to the existing railway between the two cities, in conjunction with exploring options to route freight services away on their own dedicated infrastructure from the route that MPR fast trains will take. The rerouting of slower freight services really unlocks the capacity to implement speed improvements on the existing railway alignment. So, however, this does involve increasing the existing East Coast mainline speeds to 140 miles per hour. Now, this presents a couple of challenges, as I'm sure everyone in the audience is probably thinking now. Some current standards for track and electrification only cater up to 125 miles per hour running, so there's some work to do there. And the existing overhead contact system, or OCS, installation is the Mark 3B type, first installed for 125 miles per hour running between 1986 and 1991. So the existing OCS system is currently fit for 125. Now, that equipment was originally tested for 140 miles an hour. It's never been formally passed for operating at that speed. And the current scope of MPR made the conservative assumption that all of that OCS would need renewing, and that it's unfit for 140 miles an hour. Now, you can imagine that some of the scope for that is extremely expensive, and I'm thinking particularly the 4-track alignment just north of York, where we've got 4-track headspans. Very, very expensive. So, further work's been undertaken to investigate if the existing installation can be suitably upgraded to 140 miles an hour to suit the higher speeds. This work involves dynamic analysis using survey data from Network Rail's measurement train and computer simulation to determine how the headspans will perform at the higher speeds. Now, initial results of this dynamic modelling are positive, and we're currently working through the scope of upgrades required for 140 mile per hour running with OCS discipline experts and in dialogue with the asset team at Network Rail, because achieving an upgrade way forward, which will retain the majority of the existing asset, is a big opportunity. It has the potential to significantly improve affordability and the business case for MPR, and it has huge implications in terms of reducing potential disruption to the existing network. It also has implications for sustainability, as it means less new equipment is required, with all the positive waste, carbon and climate implications that that decision would bring. Finally, I just want to mention that this work only represents the technical feasibility of running the system at that speed. It's been done in parallel with a range of other activities. However, I think you'll agree this work and its potential, it's really exciting because of the amount of work that it could reduce in the scope. I'm going to talk to you a little bit about Leeds to Hull. So MPR's aim between Leeds and Hull is to deliver 2 fast trains per hour in each direction, which connect the two cities in 45 minutes. This can be achieved by upgrading the existing rail link between the cities that's there today. However, it requires speed increases to be implemented. Now, the key issue with any route to Hull is that we have to cross the Vale of York floodplain. And I'm sure it's no surprise to some people in the audience today that the floodplain is characterised by lots of areas of very poor ground stiffness. Now, poor ground stiffness presents problems for increased railway speeds and the displacement wave created by the deformation of the subgrade, also known as the Rayleigh wave, because it travels much more slowly in poor soils. This effect peaks at what's known as the critical velocity, and in poor stiffness ground, this occurs at lower speeds than in good ground conditions. Now, I really struggled with that when I was learning to be a P-way engineer, so the best way that I find to understand critical velocity is breaking the sound barrier on rails. Instead of catching up with the compressional waves in air, as Concorde did, it's catching up with the slower Rayleigh waves in soil, which means it happens at much lower speeds than Concorde and with potentially more adverse effects. Now, you might be wondering, why is the track CRE worried about this? Surely it's a geotechnical issue. Well, as speeds approach critical velocity, this can lead to track deformations. It creates problems for track maintenance, passenger comfort, and it impacts on properties adjacent to the railways and causes safety issues. So basically, it's everything that would keep a track CRE up at night. This is caused by this. And in summary, if we want to cross the floodplain at a higher speed, then we may need to undertake significant ground remediation works to do that. So how has MPR managed this risk? So initially, in the absence of ground investigation data, assumptions have been made on the stiffness of the ground. And that's using geological mapping and things that are available to us. And this is the general methodology that's been applied across all routes on Northern Powerhouse Rail. In areas where the track ground is considered poor, extensive track bed remediation was initially scoped to deal with any potential critical velocity risk. This typically requires micropiling between sleeper bays, which comes at considerable expense and massive disruption to the existing network during construction. And just to give you a figure, 125,000 metres squares of remediation was scoped for this route originally. So that's quite a significant amount of work. Now, for the Leeds to Hull route, given the unique ground conditions that I described earlier, a bespoke approach has been taken. Desktop work to test whether or not the scoped remediation is too conservative has been undertaken and has highlighted the possibility to save up to 70% of that ground improvement works that we scoped originally if less onerous assumptions are made. So ground investigation is now underway to understand and unlock this reduction in remedial works, and you can see a picture of that taking place over the summer, just in the top corner there. Now, it's not typical to undertake GI at such an early stage of a project. We're not even in GRIP 2 yet with this scheme. But for MPR, this targeted approach for GI, where it can have the biggest impact, was considered a robust approach. The final thing that I'm going to talk to you about is Sheffield Hub. Now, one of the novel things that I noticed when I started working on Northern Powerhouse Rail was just how much time you spend thinking about other projects. So at Sheffield, we're looking at tram train solutions as an extension to the existing tram train pilot in Sheffield. Now, for those of you that don't know, the existing pilot is an extension of the super tram network on the existing rail network between Sheffield and Meadowhall. It's as simple as that. And it uses bespoke low-floor vehicles that are suitable and safe for operation on the heavy rail network. As part of an integrated solution for MPR in the South and East Yorkshire regions, the MPR team worked closely with Sheffield City Region, one of TfN's partners and stakeholders, and other key stakeholders, to develop proposals which extend the tram train from Meadowhall up to Doncaster. Now, you might be asking yourself, how is this going to deliver fast services for MPR from Sheffield Hub? So Sheffield Station is an extremely complex site. Many people making journeys in the region have Sheffield as their ultimate destination, or they use it as a way to transfer to fast trains, travelling to other major cities in the Midlands and beyond. In conjunction with this, the site that Sheffield Station sits on is constrained. It's entirely bounded by infrastructure, including tunnels at both ends. And the level of the station relative to its surroundings is very challenging. And finally, the building is Grade 2 listed if you just wanted to make it even more difficult to do. So all of this together means that increasing the capacity of Sheffield Hub to meet the demands of the future would mean a massive degree of disruption to implement an infrastructure solution at the station. It was clear that the MPR team needed to work with local stakeholders to come up with a different way of looking at this. So what if we stop thinking of hubs as specific station locations and start to think of them as destinations which people want to get to? The existing tram train and super tram network already provides an excellent connection to the destination of Sheffield, and it delivers people right to where they want to go, to the offices and the leisure facilities that they're trying to access. It includes a stop at the station that's not within the constrained envelope of the heavy rail station as well, so that's really beneficial. So by supporting local proposals to extend the tram train service from Meadowhall to Doncaster and make enhancements to the existing system, this enables train paths and crucially junction moves at both ends of the station to be freed up at Sheffield, which in turn gives the capacity for MPR fast services without major disruption to the station during implementation and all the costs and disruption to the existing network that would happen there. So this is looking at a local solution to deliver a requirement rather than straight away going to a heavy rail solution to try and deliver what we need. Okay.
So I was recently reminded by our comms team that at the end of any presentation you should leave the audience with 3 key messages. So that's what we've tried to do on this slide. Okay, firstly, MPR needs to provide good value for money, but must be transformational to deliver for its end users, the people of the North. Equally though, in a time of constant change, it must be adaptable. Resilience and reliability needs to be at the heart of whatever the ultimate solution is, and it must be future-proof to allow for growth or adaptation beyond MPR.
Secondly, MPR is part of a bigger picture. The government's integrated rail plan, which you've heard so much about today, is due to be published soon, possibly tomorrow. And MPR is likely to be part of an integral aspect of improving transport in the North. It's dependent on the right incremental development taking place across the network, and we need to make sure that the solutions we develop integrate with other projects and local transport systems as well.
And finally, if you take one thing away from what we've said today, it's that MPR has many challenges to overcome. Difficult topography, challenging ground conditions are just some of the challenges that MPR faces. We will need to develop solutions that are innovative, both in concept and in implementation, and we will need the supply chain to come together and be versatile to help us to overcome these challenges. So that's it for our presentation today. If you've got any questions, obviously come and see Jenny and myself. Thanks so much for listening, and enjoy the rest of your day.
Thank you.